I wrote JAMB last year, and I did not use the calculator that they provided for me like that. The reason is because this calculator is a waste of time. Before I click this one and click that one, my time is already gone. And number two, it has limitations like no square root, no logarithm. It is because, and I was able to get a very high score. You can see my score right here. So you can see my score right here. You can see my math score and you can see my physics score. So the reason why I was able to have this very, very huge score is because I am familiar with some math concepts that I'm about to introduce to you in this video. And the first one is direct and inverse proportion. These videos, they are in parts, so you can check the playlist for the part one. Now, the first thing is you are going to be tested majorly on direct and inverse variation. And it's not going to be one question, it's going to be two questions. It's going to be like at least 10 to 12 questions that you will be tested on direct and inverse proportion. So how do you go about it? We have the direct one and we have the inverse. Basically, direct means as one increases, the other increases. If this one decreases, the other also decrease as well. That's what direct is. So, and in that place, I've given you the overall expression. You introduce a constant k if y and x are the variable you are dealing with. That means that if you solve for k in this place, y over x equals k. And as you can see, k is a constant. That implies that the ratio y over x is always going to be constant, no matter what the value of y is, and no matter what the value of x is. So you have y1 over x1 will then be equal to y2 over x2. And that's basically how that works. Now, what about the inverse variation? Inverse variation means that as one goes down, the other goes up. As one goes up, the other goes down. And from this place, you have the final expression y equals k over x. So in this place now, you see that yx equals k. So that implies that the product of the two things that are inversely proportional will always be constant. And that implies that y1 x1 equals y2 x2. This should remind you of your Boyle's law. So let's take some of the questions that are here. This one is just directly Boyle's law, so you can just apply that. Pressure is proportional to volume, so that is proportional to the inverse of volume. So P1 V1 equals P2 V2. Now, sometimes when you are dealing with problems like this, I can say U varies inversely as the square of V. So you can see in this case now, there is square being involved in this process. Since I have U and V square being varied, and I told you that when something is inversely proportional, all you have to do is to make sure that the product of the two of those two things are constant. So that means that I can say U1 V1 squared will be equal to U2 V2 squared. And with this, I can solve for any of the unknown among them. So you can see what I'm talking about. The whole idea of this variation is just for you to know whether the product is the one that is constant, that is in the case of inverse, or whether the ratio is the one that is constant, that is in the case of direct variation. So don't forget to always apply whatever elements, whatever arithmetic operation that you have been given. Let me solve question number 4. You can attempt the rest on your own. In this situation, 5 workers finish a job in 12 days. How many days will it take 3 workers to work on this thing? Work is done by 5 persons. They finish in 12 days. What will happen if 3 persons should do the same work? That means that the number of days will increase. That implies that the more workers you have, the less number of days. The less workers you have, the more number of days. This is an inverse proportional. Don't stress yourself. Just say 5 times 12 will be equal to, what we're looking for is number of days multiplied by how many workers? 3. So you can see what I did now. The first information, I just multiply them based on what I already explained earlier to you here, that when it is inverse variation, you just find the product of these things at a given time and it's going to be constant. So in this place, 3 in 12, that's going to be 4. And you can say 4 times 5 is 20. So the number of days is going to be 20 days. So let's move on to the topic number 12. This one is rate of change. What is change? Change is simply the increase or decrease in the value of something. So if you have a value A and you move to value B, the change is going to be B minus A. Depending on whether B is more than A, that will be an increase. If B is less than A, that will be a decrease. But this change, we can measure it with respect to something. Mostly, we measure it with respect to time. That's why I've put it here that rate is change with respect to what? Time. And you will see that in your velocity. Like this question says that if the velocity of something increases from 10 to 40, what is the acceleration? Acceleration is change in velocity over time. And that implies that here I can have 40 minus 10 over 6. That will be 30 divided by 6, and that will be 5 meters per second. In this place as well, population growth from 2000 to 25 in 5 years. What is the growth rate? That is, how much are they growing per year? That will be 2,500 minus 2,000. That's going to be 500 divided by 5, and that's going to be 100 per year. Let's go to topic 13. Topic 13 says, so we're going to be learning how to do conversion in this place. We're converting different units. Most people can convert when it is just one thing, from one thing to another, centimeters to meter, millimeters to meter. But what about if you have compound units like kilometers per hour? Very easy. If you want to convert something from kilometers per hour to meters per second, just divide that thing with 3.6. And where did we get that 3.6 from? Let me show you from this place. You would notice that kilometer is actually, kilo is 1000, while hour in seconds is 60 times 60. That is 60 minutes multiplied by 60 seconds. And that will be 1000 divided by 3600. So whatever it is that you're working with, so let's say I'm converting 108 kilometers per hour now to meters per second. So let's quickly do that. So 108 kilometers per hour, it means kilometer over hour. So that's 108 multiplied by, kilo is what? 1000 meters over hour is 3600 seconds. So if I change this whole thing now let me leave the meter per seconds part. So that's 108 multiplied by 1000 divided by 3600 multiplied by meter over seconds. So you realize that this is the same thing as 108. If I change this multiplication sign, I change it to division sign, this will change. So 3600 over 1000 still multiplied by meters per second. So in this situation, that implies that we have 0 goes here, and 36 over 10 is 3.6. That's exactly where that expression is getting from. So to convert from kilometers per hour to meters per second, just divide by 3.6. And if you want to do the converse, just multiply by 3.6. So for these other ones as well, I've listed it. Just check it out. These are the common ones that you always find. Look at this centimeter cube to meter cube. Just divide it by what? 10 raised to power what? 10 raised to power 6. So you can practice as many as possible on your own. Now let's go to the next one, reading and plotting of graphs. This one is also very important. You need to learn how to read graph, and you need to learn how to plot graph. But it's very easy. One of the things that you need to understand is that there are 3 major types of graph that you'll be asked. I'm going to be teaching you linear graph first. So for linear graph, you can have a graph like this. You can have a graph that is going like this, and you can have a graph that is flat like this. This graph means whatever it is that you are comparing, it is increasing, more like direct variation. This one means whatever it is that you are comparing is decreasing, and this one means whatever it is that you are comparing is constant. But one thing you need to pay attention to, especially for this one, is where is this guy touching the y-axis? So sometimes it can touch the y-axis. Let me show you. It can touch the y-axis here, it can touch the y-axis here, and it can go in this manner. This one means that it touched the y-axis on the positive side. So that means that it has a positive y-intercept. This one means it touched the y-axis on 0, and this one means it will touch the y-axis on a negative side. But the 3 of them, they are still what? Increasing graph. And basically, the increasing graph, we have a slope that is positive. A decreasing graph, we have a slope that is negative. A constant graph, we have a slope of 0. Now, but if it is curved, what kind of graph will you deal with? If it is curved like this, it means decreasing. This is a decreasing graph, exponentially decreasing. If you have a graph of this nature, it is exponentially increasing. So basically, you're going to just trace it. Are you going up as you are going from left to right, or are you coming down? That's how you test for a graph. So let's see some of these questions. It says a velocity time graph shows that velocity equals 20 meters per second at t equals to 0. Velocity is 0 at t equals to 5 seconds. What happened to the object? Did this guy accelerate? So let's just plot an arbitrary graph right here. So at t is equal to 0, you have 20 meters per second. So 20 meters per second at t equals to 0. So let me note this point. When t equals 5 seconds, so you have 5 seconds here. What is your v? Your v equals 0. So what do you notice here? If you connect the two of them, the 2 points, you can see that this is a decreasing graph. Since we are dealing with velocity versus time, we are dealing with acceleration. And since it's a decrease in velocity with respect to time, that means that the body decelerated. The body what? Decelerated, or the body retarded. And that is basically how you answer problems like that. You can attempt the rest of the question as well. So let's move on. Gradient and slope. Now this one now will help you understand that straight line I just gave earlier. So I was talking about slope when m is positive, when m is negative. How do you find the slope on any given graph? Basically, if you have a graph, a straight line graph now this time around, you just pick any two random points. You pick a random point. On this point, you trace it down. Let it be your x1. On this point, let it be your y1. That will be y1. And this point, you have x2, and this one will be your y2. Also, what matters most is that you picking the correct thing. I mean, whenever point you are picking x2, that's the same point you are picking y2 as well. So if you look at this graph now, let me pick my points. So if I have these 2 points, I can call this one my x1. That means that this one too has to be my what? y1. I can call this point my x2. This one too has to be my what? y2. That's basically what it is. And what's the formula for slope? Slope is y2 minus y1, y2 minus y1 divided by x2 minus x1. So I've explained that positive means increasing, negative means decreasing, and if it is 0, that means that it is constant, nothing is changing. And steeper also means larger gradient, and it means faster rate of change. What I mean by steeper is that if you look at this set of lines, look at this one, look at this one, look at this one. Now the first one is steeper than the rest of them. So the steeper you are, the higher your slope is going to be. So in this place, you should be able to find the gradient and the slope of any of these in any of these problem. Let's move on to topic 16, interpreting charts and tables. For each interpret chart, we have charts like pie charts, we have bar charts, and we have tables. You need to be able to identify row and column correctly. Now for pie chart, this is how it works. Whatever value that is there divided by total times 360 degrees. So if you have a pie chart of this nature, you should know that everything will divide all together into 60 degrees. Into 360 degrees. So you can have something of this nature. Yeah, this is a pie chart. So if you have A here, you have B here, you have C here, you have D here. So the total of A, B, C to D, that is the total that I meant here, and each value. So A divided by A plus B plus C plus D times 360 degrees will give you the corresponding angle of A. But if also what you have already is the angle that A subtend, let's say the angle is theta, and you want to find the value of A, that will be theta divided by 360 degrees multiplied by the total thing that you are dealing with, which will be A plus B plus C plus D. That's how I interpret pie chart. For bar chart is going to have rectangular lines. So on the rectangular lines, you can easily check the frequency. That is, how much do they occur in a given instruction. So you can practice more and let me know in the comment section if you have problem with anything. I can make specific videos to explain specific questions. So next topic is area under a graph. This one is common for science students. Science students in physics, you will need this one very well. Let me explain the concept of area under a graph for you. You see, the shape that a graph gives. So let's say you have a graph of this nature. You have a graph like this. Now, if this is a velocity time graph, area under a graph, take note, area is always the ratio of the vertical area is always the product of vertical multiplied by the horizontal. So in this situation now, the area in this place is going to be, this is velocity multiplied by time. And velocity multiplied by time will give us displacement. That means that the area under a velocity time graph will give displacement. Unlike slope, slope is always the vertical over what? Horizontal. But area is always the. So if I want to find the displacement of this guy that went through this journey now, what am I going to do? When you look at this entire thing under it, we have a shape. But you have to break that shape down into different parts because it does not give a regular shape. So you start from this edge, you can break this down. When you look at this thing I just broke down now, this is a trapezium. So whatever this place will be your A, this place will be your B, and whatever this place is going to be your height. So the area of a trapezium is 1/2A plus B times height. And you can see that the lacquer part as well is also another trapezium. So you find the area as well. When you are done, you can add the two results together and you will find your what? You are going to be able to find your total displacement for the journey. And it's not only trapezium that you have. Sometimes in the question, you have rectangle, you have triangle as well. All you have to do is to be able to split those things into different shape altogether. So let's see if we can have something of a complex one. Yeah, say an object accelerates from 0 to 24 in 6 seconds. Find the total distance, find the total distance covered. So this means that it moved from 0 to 24. So let's see. The initial speed is going to be 0. The final speed is going to be 24. It did this one at 0 seconds, and it did this one at 6 seconds. So let's trace it there at 6 seconds. So if you plot the graph is going to be something of this nature. And so what do you get here? You can then complete the area under this graph. This is a velocity versus time graph. What kind of shape do you have here? A triangle. So your area, which is the total displacement or total distance covered, that will be 1/2 base times height. The base is from 0 to 6, so that will be 6 multiplied by the height is going to be from 0 to 24, and that's going to be 24. So this is going to be 12. So 12 times 6, that's going to give us 72 meters. So that is how you use area under a graph to evaluate anything that you need to evaluate. Okay, so that's that about area under a graph. Don't forget, area is product of vertical and horizontal, while slope is the ratio of vertical to horizontal. Next, we have area and perimeter of basic shapes. Area and perimeter of basic shapes. Now, for this area and perimeter of basic shapes, we have the key formula that you need to know: the circumference of a circle, the area of a circle, and triangle and perimeter of a circle. This one is very, very easy. Now, the reason why I denote this one is because if you are solving any problem that has to deal with this kind of question, you should be able to be familiar with some of the common areas and all of that. So that one is just easy substitution, which I've also explained in part 1 of this video. Now, you need to know the volume of some solid shape, especially a sphere and a cylinder. You need to know how to find the volume. I need to relationship that density equals mass divided by volume. Density is what? Mass divided by volume. So look at a metal block. A metal block has volume 200 cm cube and mass 1,400 gram. So what is the density? Density equals mass divided by volume. That's going to be 1,400 divided by 200. So that is going to be 7. So the density is 7 gram per cm cube. 7 grams per cm cube. You should be able to get that as well. Now, let's move on to Pythagoras Theorem. What is Pythagoras Theorem? Pythagoras Theorem is simply what most of us are familiar with. C is the hypotenuse, which is the longest side, and A and B can be anything. But one of the mistakes that most people make is that when they are applying Pythagoras Theorem, they don't know how to identify which one is the opposite or which one is the adjacent. Let me show you something now. If the angle here is theta and this is the right angle, of course, this is the hypotenuse, our side C. Opposite and adjacent are determined by the angle. This angle is facing this side. That means that as far as theta is concerned, this is the opposite. and this right here is the adjacent. So it's not necessarily that this side will always be the opposite. Opposite and adjacent are determined by the angle that you are dealing with. So let's see. A ladder which is 10 meters long leans against a wall. So if this is the wall and this is the ladder, we've been told that the ladder is 10 meters long. Its foot is 6 meters from the wall. That means that it's 6 meters away from the wall. 6 meters away from the wall. How high does it reach? So we're looking for the height here. So this time around, we're not looking for the hypotenuse. We are looking for the what? Either the opposite or the adjacent. And this is what you use to calculate that. So that would just be, the height will be the square root of 10 squared minus 6 squared. And square root of 10 squared minus 6 squared, that will be square root of 100 minus 36. 100 minus 36 is 64, square root of 64. And that's going to be 8 meters. So that's how you deal with Pythagoras Theorem. Make sure you are familiar with that. Don't forget, these are basic maths. I'm not doing too much. Now, basic trigonometry. Trigonometry is one of the bedrock of mathematics. You need to know everything here. So that is where you have your SOHCAHTOA. Your SOHCAHTOA. So as you can see, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse, and y tan is opposite over adjacent. But one thing you should also take note is that tan is also sine over cos. Take note of that. And these are the special angles that you need to know offhand. So today, just master this. Just master this. In some of my videos, which you can check, I made a full video explaining how we got all of these special angles and how you can get it as well without using calculator in the exam hall. So please pay attention to all these guys very well. And this will help you very well whenever you are resolving something, maybe to the horizontal component or to the vertical component. For instance, this one says find the horizontal component of 20 Newton force at 30 degrees to the horizontal. So you have the force here. The force is 20 Newton and is at 30 degrees to the horizontal. So the horizontal component is going to be 20 cosine 30 degrees. So from here already, you know that cosine 30 is 0.87. And that is going to be 20 multiplied by 0.87. So that's just basically what you need to know. Now let's talk about circle, some of the circle properties. Now I've given you the circumference and the area already. Let's talk about the diameter. Diameter is always 2 multiplied by radius. So be careful when you are solving a problem and you are given diameter, always convert it to radius. If radius is what you will need, it is very, very important. Next is circumference. It can be 2 pi r and it can also be pi d. That is if you are using diameter. And lastly is angle at center equals 2 times angle at circumference. Now, if you have a circle, this is the best way to remember this particular theorem. Draw a line that is cutting through the center and then try to form an angle here. So you already know that twice angle at the circumference is angle at the center. Now, what do you think the angle here is going to be? This is going to be angle on a straight line, which is what? 180. Automatically, this guy cannot be more than 180. It will be less. And that will be what? Half of it. So that's 90 degrees. So with this now, you can easily tell when you are dealing with something else. So, and I say, let's say I give you any crazy angle like this. I give you something like this. Then I say the center, the angle subtended at the center. Let's say, for instance, this angle is 160. So automatically you know that this angle has to be what? The half of that angle. And this is going to be 80 degrees. So this is one of the basic things that you need to know about this particular concept. So I'm done with this part. That is the part of geometry. This part takes care of rates, graphs, geometry, and trigonometry. Like I said, these are just revision thing. Some of these topics I've made very detailed video on them as well. So the next one we're going to be dealing with in the next chapter is going to be statistics, commercial math, and general skill. Don't forget to hit the subscribe button and like and comment as well. I'm also going to be answering your questions in the comments. I'll see you in the next one.